Okay, so in this video we're going to do another example by using, we're going to do more examples of using the greatest common factor to factor polynomials. Okay, so let's get started. So the first one is we have this one. So again, what's the largest factor of the coefficients? Well, in this case we don't have the greatest common factor we can factor out as 1, so that's not going to help us. But we got a y. We can factor out what's the largest exponent that we can factor out? Y squared. So we can write this as y squared. And then of course, what's going to be left over? Well, 9y cubed plus what? 1. Now, if you're ever in doubt, or if you want to check, which I highly recommend that you check your work to make sure you're doing it right. Don't just get an answer and move on, because you might be doing it wrong. So, what would you do? Well, remember, factoring is using the distributive property in reverse. So if I want to check to see if I got it correct, go the other direction and see if I get back to where I started. So, I'm going to distribute the y squared. So y squared times this, well, y cubed plus y squared gives me y to the 5th. So I get So I get 9y to the 5th. And then y squared times 1 gives me y squared. So I get right back to where I started. I did it correctly. Okay? Okay, now, what about this one? What's the greatest common factor that I can pull out of the coefficients? Well, in this case, it's 2. Okay? So 2. And then now look at the x's. Well, I don't have x's in all of the terms, so I can't pull out any x's. But I do have t's. Hold on, just want to make sure I wrote this down right. Yes, it is. So there's one t in each of them, so I could pull the t out. And so what's that left over? What gets left over? Well, I'm going to get 3x squared plus what? 4x minus 6. And I'm done. And the last one, look at this one. So here, look at the coefficients. So the greatest common factor I can pull out of the coefficients is 7. Okay. Now, what else can I pull out? Well, in this case, I've got a binomial that is a common factor. See, I've got m plus 1 to the 3rd, m plus 1 squared, and m plus 1. So I can factor out an m plus 1. So let's do that. So now let's factor out m plus 1. Now, what does that leave me with? Well, it leaves me with what? 2. Let me do this a different way. This leaves me with 2 times m plus 1 squared minus 4 times m plus 1 minus 1. Now that's what I end up with. Now, we can simplify this too, right? Because we're not done with this one. Okay? The other two, but this one we can simplify further. Okay, so let's see what happens. Well, this is a perfect square, right? So this is going to be 7 times m plus 1, and this is going to turn out to be, let me do this. So this is going to be 2 times m squared plus 2m plus 1 minus 4m minus 4 minus 1. Okay. Now I'm going to distribute the 2, so I get 7 times m plus 1 times 2m squared plus 4m plus 2 minus 4m minus 5. Okay, so far so good? So now let's simplify. So we got a 4m here, that cancels with this 4m here, and so we end up with 7 times m plus 1 times the quantity 2m squared minus 3. Oops, I forgot the 1, dropped the 1. And that's it. Okay, that's it. See you next time.